Okay, thank you for everybody joining this session today. And I'm your host, Anne. Today, we will have three speakers sharing their insight on how to attain low carbon excellence in manufacturing. Okay, so our first speaker would be Nicholas, and followed by me, Anne, and Harry. Okay, right. So without further ado, let's start our first session with Nicholas.
Here we see this 15 minutes talks agenda and topics, focusing on manufacturing, energy and greenhouse gas, GHG. Welcome and thank you for taking the time to listen to this. First, I will talk a little bit about who I am, but mainly why so many manufacturers and machine creators of today are reaching out to me for information and solutions within this area. After that, we will talk about what energy, greenhouse gas, GHG, the GHG protocol, and emissions are. We will also look at emission scopes and how they are used to measure GHG, building the foundation blocks for reporting and giving valuable insights into factories and machines. Then we will look at laws and legislation that is already changing the game, soon affecting everyone. Finally, we will look at the future of manufacturing and machine builders, implementing this and what Advantech is already doing to help you get ahead of the game, to get you started, become more competitive, and possibly even changing your business models. My name is Niklas Kvarnström. I'm the founder of Ambient Technology. I also work as an WISE IoT consultant for Advantech Europe and as an expert focusing on industrial transformation of factories and deep diving into software and hardware wherever that's needed. After decades of visiting hundreds of factories and being a programmer for over 30 years have given me a deep understanding of what is needed to help manufacturers, but also insights of what is done and coming. Now let's look at the basic terminology. Greenhouse gas GHG protocol. The GHG protocol provides standards to measure and manage climate warming emission. It covers the normal 7 gases, focusing mainly on carbon dioxide, CO2. It is also responsible for the terminology of scope 1, 2, and 3 that we will look at in more depth soon. Greenhouse effect. Earth is surrounded by the atmosphere. In daytime, the sun shines through the atmosphere, warming its surface. At nighttime, the surface cools and heat are released into the air. Some of that heat is trapped by the gases in the atmosphere. That's the greenhouse effect. Being net zero. Net zero refers to the balance between the amount of greenhouse gas that's produced and the amount that's removed from the atmosphere. When what we add is no more than what we take away, we reach what's called net zero. Now we will look at the scopes of emission. The first scope is a direct one, emission from sources on site, meaning that we can think of the word burn, factory fumes, leaks, and venting emissions from gas networks. It's easy to calculate. In short, it's direct emissions from company-owned and company-controlled resources. Those are all included in Scope 1. Scope 2. Indirect emissions from energy utilities. We can think of the word buy. Purchased electricity, steam, heating and cooling. Keep in mind though that the factory is responsible for the GHG emissions being created as a user of that energy. It's moderate to calculate. In short, It's indirect emissions from the generation of purchased energy from a utility provider that are included in Scope 2. To put it another way, all GHG emissions released into the environment as a result of the use of purchased energy, steam, heat, and cooling. Scope 3. Indirect emissions of the chain supply or service. We can think of the word beyond. Sold gas or electricity used by customers. Business travels, purchased goods and services. This is very hard to calculate and normally the absolutely biggest one. An example is a tea company. Let's say that you create tea. One of your biggest scopes of emission would be scope 3 because everyone needs to heat their water in order to make their cup of tea after buying it from you. Now let's look at EU and laws regarding GHG emissions. From the chart, without deep diving into it, we can clearly see that we have to change a lot. We have all heard about GDPR, General Data Protection Regulation, that changed all businesses done in and with EU. The climate law will soon have the same impact, if not more, and affect every company according to the scopes of emission we looked at earlier. The European climate law, in short, is legally binding, setting the target of net zero greenhouse gas emission by 2050. All member states are bound to take necessary actions to meet this goal, meaning factories in every country. Already, the target for 2030 is included in the new law. But if we look at manufacturing specifically, normally we measure OEE, meaning that we want to see how well a manufacturing operation is utilized compared to its full potential during the periods when it's scheduled to run. But by measuring electricity usage of a production, we can get a much better foundation for pricing what we create. We can also find out what is energy costly and improve that. And if there are leaks, natural gas. In case of energy anomalies, we can activate preventive maintenance on the spot to avoid unplanned stops of production. If we look at machines and machine creators, they seldom know anything about the machines they've just sold or how they are being used. If instructions for warranty is followed, if remote repair is needed, many don't even get any data regarding the machine once it leaves the shop. But by measuring electricity usage of motors in the machine and other parts, we can look at energy anomalies and once again do preventive maintenance before the machine takes real damage or stops production. New services can also be created with the insights of new data about how the machine is being used. We can create alarms for maintenance. We can also send parts needed and ship it to the factory before it breaks down. Think about the enormous lead times we have today after COVID. Data will also feed the innovation for that machine creator. And as mentioned before, in general, to have production or machines reporting GHG emissions and energy usage will be a big competitive advantage very soon. Many are already asking for it, as mentioned before, the different emission states reports for products and producing material. Ensuring a machine is energy efficient and transparent about that, as well as production, will be key. Laws are soon to be real. To be prepared is never a bad thing. To show that one is using only energy needed and not creating too much GHG emission will be a strength. When anyone is looking for a new production line or a machine, questions regarding this will soon be mandatory. So, what is Advantech doing to help you get a better understanding of your GHG and energy usage? Normally, you might hear about the 7Ds, different ways of shaping tomorrow's energy systems. But what we are going to focus on today is the sixth one, digitalization, and more specifically, how to understand the needs a factory have, what are the costs for production, and everything else we've been talking about so far. All in all, Advantech is bringing to the table now software to help boost productivity, meaning automated recording of equipment production that enables efficient adjustments to parameters and processes, enhancing overall equipment efficiency, like OEE mentioned before, but also control energy consumption, effectively reducing energy consumption by calculating carbon emissions and energy usage for each machine and product. So, how does this work from sensors to insights? There are different ways of doing this. We can either get that data from a machine in a production line through its PLC, but we can also do it from sensors installed, current transformers, going through a power transformer like WISE M501, sending that data to a gateway like ECU 1051. That gateway will then send that data through the MQTT protocol to Advantech's parameter set. And this is where the magic happens. This is where you connect different data channels with certain values. For example, energy, the status of the machine, the quantity of products produced, etc. You also transform that data due to formulas here. From the parameter set, you can send that data through GraphQL to the OEE Pro, an iApp within the iFactory family of Advantech. Here you select and manage assets. You can define KPIs and make equations. You can bind equations with assets. You can view hourly and daily KPI reports and more. And most importantly, you can visualize all of these on dashboards. Here we see insights of assets and how they are actually using their power consumption, carbon emission, consumptions per piece produced, and carbon emission per piece produced. Understanding the energy consumption and carbon emission generated by each machine, and further combine that with work orders, and to calculate the carbon emission energy consumption for each production unit will help enterprises to calculate the energy consumption of the products produced. This is where you get and store all your data at one single place. The last step, of course, is to show and visualize all these insights, the product carbon emission calculation and everything else. First of all, as we see here, we can see a status analysis of the machine, its performance, its state, and monitor the condition of the machine. We can also look at the product output analysis and more. We can look at product record table, including work order, production start time, production end time, machine operation time, actual output, defect quantity, unit energy consumption, maximum energy consumption, all in order to get insights into our production and energy usage. Now we are looking at one particular machine. And as we can see, you can see the carbon emission of today and in total, the consumption of today and in total, but also the power usage in real time and peaks. You can of course combine all of this in Advantech's dynamic chart tool. That's all for me. Thank you very much.
Okay, thank you to Nicholas for his introduction on the EU carbon laws and how it will impact the upcoming manufacturing starting from 2023 and with all the border tax requirements. So we see that there are things we can do with IoT data to help ease the difficult of transition. And now I will be introducing the functionality in detail. Okay. Hi, this is Product Manager Anne. I would like to start this part by a question. Has your company implemented automation? Everyone has encountered traditional factories that may be constrained by inflexible production process and rigid production line setup leading to inefficiencies and low productivity before deciding to purchase equipment. Or because of manual production, it is difficult to monitor and correct defects in real time, leading to unstable quality, resulting in counter-production and customer complaints. Moreover, because of excessive reliance on a large amount of manual labor, not only is the cost of labor too high, but it may also be affected by labor shortage. Therefore, the company evaluated that the introduction of automated equipment was the best solution to the above problem. However, has productivity truly increased after equipment automation? FactoryOEE can help you to answer this question. Advantech FactoryOEE is a tool that can support your company understand whether your equipment's productivity is improving or not. It is a cutting-edge factory management tool designed to elevate production efficiency and prioritize sustainability. Through sophisticated data analytics, it provides real-time monitoring of energy consumption, effectively reducing carbon emissions. Our commitment lies in creating an efficient and eco-friendly production model, optimizing your factory for peak performance while minimizing environmental impact. Experience the future of smart and sustainable manufacturing with FactoryOEE. I'm going to use this architecture to open up the look of this product. There are many possible sources of data for the plants. For example, PLC-based device data can be transferred to our data platform, RTN, via Mobox or OPCUA. Other protocol can also be imported into RTN after conversion to MQTT via Advantech's AG-Link and Web Access. Additionally, databases and sensor signal can also be connected directly to data platform, RTN. After RTN collects various machine data, it is pre-processed and then dropped into FactoryOEE and presented. This is the whole process from data collection to presentation. This is a very classic application scenario that FactoryOEE can provide. A production department may have several machines or even hundreds or thousands of machines. Traditional manager will have to go to the shop floor to check the status of each machine, or go through the operator's hands copying of the data to understand the situation on the shop floor. This method is not only time-consuming, but also prone to human error. FactoryOEE can greatly improve in management efficiency and reduce human errors. The machine data from the shop floor is transferred to FactoryOEE's data platform, RTN, through Gateway. If manager want to see not only machine data, but also data generated from systems such as ERP or MES. The data platform RTN can also receive data from the system. After pre-processing and analyze, it is presented in the form of insight reports and dashboard. For the shop floor manager, the real-time report and dashboard helps them to keep track of the status of each machine in real time. For decision makers, the analyzed data can be used to make the right decision. The following insight report is provided by FactoryOEE as a reference from your decision making. This report is for the SMT production line. The SMT L1, M1, M2 presented in the leftmost line present the SMT production departments, line 1, machine 2. The middle line matrix is a list of metrics that manager want to keep track of, including availability, performance, quality, OEE, and so on. Finally, the table on the right presents the indicator in chronological order. For example, we can see that SMT L1M1 has a quality of 97% and OEE of 129% from 9 o'clock to 10 o'clock. Managers need to manage abnormalize, not normalize it. Therefore, when a manager sees an unreasonable OEE of over 100%, they can continue to check and inquire about the unreasonable area. Continue with the report generated earlier. In the formula presentation, it is also possible to add production work order, product number, energy consumption, and carbon emission data. Because there is work order information and carbon emission and energy consumption information, FactoryOEE is able to analyze the energy consumption and carbon emission to each piece. Taking this graph as an example, we can know that the energy consumed by the M1 machine in this hour is 45 kWh, and we can get the carbon emission information of 22.59 kilogram by converting the carbon coefficients. Further, it's possible to graph each piece consume 0.448 kWh of energy and 0.24 kilogram of carbon emission in this hour. In a market where energy costs are increasing, this information can help your company effectively calculate the cost of energy used to manufacture your products. Introducing FactoryOEE Insight Report to this point, you might want to ask me how to generate these reports. So next, I would like to use 3 steps to more detail about FactoryOEE. First, create equipment assets list. What equipment would you like management to see OEE on? Which assets have energy consumption data? Then create the asset profiles here. Here you can set the asset profile, determine equipment's description and useful life, manage the device lifecycle, and configure the monitoring item required by device. The second step is self-defined formula for device metrics. What metrics would you like to see in these devices? What do supervisors want to do with the formulas for adjusting the metrics? All these requirements can be freely added and modified by our local formula calculator. Step 3, binding formulas and assets. After creating the device list and a formula, bind the two to see the device metrics in the insight report. For example, if you want to see the OEE indicator of machine 1 and machine 2 in the reports, then you can add machine 1 and machine 2 to the OEE indicator. If you only want to see the carbon emission of M1, then just tie the carbon emission indicator to M1. Additionally to the reports, there's also a visualization dashboard. This dashboard shows the OEE from the perspective of the workshop. From the upper left corner, you can see that the total OEE of this SMT workshop is 86%, and the APQ is 91, 96, and 99%. This dashboard looks at OEE not only from the machine perspective, but also from the work order. So you can get a clear picture of what work order are being produced in this SMT shop and how many of them are being produced. You can also see what the APQ is for each work order. The two panels on the right show the energy consumption and carbon emission used in this workshop. And finally, you can also see which machines in the workshop had an alert and the duration of the alert. Additionally to looking at the productivity of an entire workshop, it's also possible to look at the productivity of individual machines. The top half contain basic information about a single device, includes current status, current production order, actual quantity and time of production, energy consumption and carbon emission, and visualization of machine status. In the lower left corner, you can see the alert that this machine has produced and the detail of the alerts. And the bottom right corner shows the detail of the production of this machine, such as actual output, good and defective products. Okay, to sum up, with the introduction of factory OEE, enterprises can fully understand whether the automation equipment has really increased productivity after equipment is automated. Also, FactoryOEE is a local, no-code tool to help enterprise effectively manage an equipment's OEE and master equipment's energy consumption, and then help enterprise to reduce costs and increase profits. That's bring me to the end of my presentation. Okay, and here's the introduction to the key features of the FactoryOEE solution. And we're also a fan of using our own product. And Advantech actually happens to have their own manufacturing site in Taipei. So now we will welcome Henry, who will be sharing a real use case coming from our own experience with you. Okay, to Henry.
Hello, everyone. I'm Henry Chen, BDN of iFactory. So for my part, I will introduce you guys a successful case actually happened in our own factory in Taiwan. I will tell you what is inside and how does it work, also the benefit after we observation. And I will connect to our live demo in the factory server. You will see some real-time data and the interface. So let's get started. So I'm going to demo you guys the SMT production lines. It has actually the most important productions we have. So we have the real-time data in the connect with FactoryOEE for many years. Operator and manager use it for many different purposes. For example, checking the delay or idle machines and to see what reason it is, and to set up the target for the production line to see if they are not able to fulfill the deadline. So we have seen some good things. Responding time has been increased, and the manager has been really efficient on the reporting in real time, accurately. The decision making will be improved because everyone look up the same table, and even they are remotely. So you don't have to wait the next day when you are doing the morning reports. You will see what happened in the previous days. It got to be solved right away for some critical missions. So those things are happened in our factory for many years. But right now, even more exciting things is we see the energy consumption is gonna be the next topics. And right now, start from 2023, OpenAI has been integrated as well. So we are seeing more value from the factory OEE here. To simply introduce you what we have here, we connect couple critical stations in the SMT lines. We have about 62 line lines running. Each machines we have to collect parts number, work order number, standard output versus the machine status, quantity, and the energy consumptions. I will explain you how we collect them and how we use it. But important is with those parameters, we can set up the instant alarms and to create different equations for the abnormality. Those alarms will push to the right person in the real time. And people right now they can open their mobile phone or website to see which stations, which parameters has been run. So that's basically the workflow we are looking for. Does OpenAI worth to invest? That's probably most of C-level managers' question first about return on investment. But first of all, let's take a look of this triangle here. You have to know that OpenAI need to be balanced because the quality, cost, and performance are actually trading off to each other. If you are focused on the very high quality, extremely high quality answers, you probably will need strong computing performance, and that will cost you a lot of money. But we are looking for the balance because right now these things are still developing. Our platform, the bad things for this is actually help you to build up your own OpenAI platform without much efforts to collect the data, fabricate the data, and to set up the prompts for OpenAI. Here's a result for operators and managers. After we practice for a couple months, you can see in the past we can call manual system. It takes about 180 seconds per questions for them to to find the root cause. But right now with the FactoryOEE plus Gen AI, it's reduced to averagely 30 seconds per questions. And what does it mean? It means they save a lot of operations hours, labor cost on it. They could be more efficient on their working. They could spend more time to focus on more valuable things. So does the manager. The improvement is actually even more impressive. All right, so look up again. We still think OpenAI is a future and is very, very important to invest right now, but with the right tools. So that's take a look of our own live demo. What you're seeing right now is the back end of WISE IoT Suite. Today we're going to introduce FactoryOEE over here. So right now I'm connecting to the server in the factory remotely. And as you can see, we have a couple different applications under the FactoryOEE, like maintenance, machine care, station manager, and OEE Pro. So today the topics here is OEE Pro. You can see I have already listed the work unit in the asset profile here between line 1, machine 1 to the end of the lines. And if you go into the detail of each machines, you could actually see some critical parameters we are connecting right now in real time, like plant output, parts number, work orders, machine status, machine output, etc. We're gonna use those because it is important for the manager that they can flexibly create their own KPI. in the KPI engines here. I'm clicking right now. As you can see, we have the KPI sample here for OEE. So you're going to focus on the availabilities of each station's performance, like output, quality, and of course, important topic today, energy consumptions, so-called carbon emissions. But we understood that you're gonna fabricate your own formula by yourself because each factory has their own rules to schedule or to make the day shift, night shift accordingly. So you could actually going to create your equations here. Make example here. For example, carbon emissions here in Taiwan, the energy consumption kilowatt per hour, we have to multiple 0.5 according to the government carbon convert rate. And then we divided actual output. So that makes us to understand the carbon emission persists in these stations. That's one of the example we customize according to the local rules. And you can do the same. So you could enjoy all of the equations here, and you could set up the alarms according to each KPI here. All right, so this is the quick introduce for the KPI engine. All right now you can see in the inside reports here, we have list of our important machines, and we just create the KPI for each machines. So you can quickly switch, and I set up in the hourly base right now, so you can see 24 hours timeline, and currently is 11 a.m. here, so we could see some real-time data running here. For example, production time, output pieces, and for example, energy consumptions in each machines. So you could also switch to daily if you want to see Sunday, Monday, each day's work order performance. You could jump into here and export it into CSV or send it by email. This is the basic reporting function we have for our users in daily. And what we're going to improve is that we integrate with OpenAI here, powered by Microsoft. And we want to improve the interactions between the users and the database. So it's going to be more real time. For example, I'm going to ask him the OpenAI a random question like the availability of SMT line 1 between 8 a.m. to 9 a.m. Okay, so it could be open on the browser base, it could open on the mobile phone. So it takes some time because, as I mentioned, right now we're still fine-tuning it between the cost, performance, and the quality of the answers. So we're going to open this tool for every users that can find a balance of their scenario. Okay, so you can see it gave me the answer that 57.4 between let's see, yeah, right here, 8 a.m. to 9 a.m. This is one of the example. You could also ask him, for example, please show me the carbon emissions of SMT line 1 today. So let's try this. It might take longer time if the question is consume more data browsing in the back end. Of course, it means more tokens will be consumed, and that of course spend more money on that. So I won't say the performance is fine tuning right now, but you can see the SMT1, the information about power consumptions, carbon emissions per pieces, and how much it is between the whole day. It gives me the answers. And other than reporting, of course, you will need the dashboard that can be displayed on site. So here you can see we also provide you Grafana-based dashboard. It's the same database that you can monitor the SMT lines between line 1 to line 9. For example, we want to look up line 2 right now. I can submit, and I can see what's happening for these 4 critical machines right now is we have 1 machine idle, and the overview OEE performance, and also the output, etc. And of course, you can go into some detail to see some more graphics visualizations. We can see like 24 hours where we have the most idle time for machine 1s, for example. And then you can, of course, check up if there's any alarm codes happened in the durations. And you could also go into the individual machine performance and to see the historical data sheet. Some sensors, some parameters can also be customized in here because Grafana we have here is really open, is an open source, and we do a lot of visualization tools and panels here, so you can utilize them very quickly and connect to the data you have on hand. All right. So that's pretty much my demo today, and thanks everyone to join. Thank you. Back to Anne.
Okay, thank you for Henry sharing this case in our own Advantech factory. So what we want to do is to help our customer and also manufacturing make things easy and to start deploying. And the solution to helps them check what's going on in their manufacturing operation, and to understand what their power consumption is during the course of production. And because in the past, power was larger, not an issue. So the cost of production usually came from your power bill. But now with the carbon border tax requirements for both the EU and also for the America, now it's becoming more important to be able to have accurate number associated to your work order. So with both on-premise and cloud option, you may easily set this up in your own production line. So feel free to reach out to your sales and locally, and they will help you to get set up. Okay. So that's wrap up our presentation for today. And if you would like to more information and also the slide recording of today's session, just feel free to reach out to us with the QR code below. And I think we still have time available for us to take some question. Okay. Okay, so here are some common questions that we get asked when dealing with customer and when we have the previous webinar. So there are 2 questions we can doing the question and answer here. Okay. So the question 1 that the customer asks us frequently previously. A lot of data we are working with now comes from MQTT. And what do you think would be the impact of UNS? UNS is a unified namespace, and toward the current approach of gathering and transmitting data. And I would like to invite Ethan to more detail about this question.
Okay, sure. Let me fill in a bit more on this question because about maybe a year or a little bit more than a year ago, Walker Reynolds, which is one of the more influential YouTube stars that was talking about Industry 4.0, coined the term unified namespaces. And it's actually getting a lot of traction now, especially with MQTT becoming more popular as the protocol for handling data from manufacturing environments. So instead of the classic ISA 95 stack, where the data must come from the equipment to maybe a gateway, and then next to a SCADA system, and then to an MES system, and then eventually to an ERP. This would be more like a pyramidal stack. But with UNS, the MQTT basically serves a central hub for data, and then the different information that's coming from all these systems, either from the classical layer tier 4, tier 3 systems with their ERP MES, or from the SCADA system, which is on the level 2, can share the data in a more flat way, so that in order to access the data, we don't need to jump through all the different layers or deal with different silos that's working with their own data. So everybody instead publishes the data they want to make available to be referred by other systems, and systems who care about that data can subscribe to the central broker in MQTT and access that data according to the topic. So we think that it's actually a very flexible structure, as usually systems in manufacturing companies are built depending on how the requirements turn up during the course that the company evolves. And in this way, we can create a central data lake where everything is available and having one single source of truth. Okay.
Yeah.
So yeah, back to Anne.
Yeah. Yeah, so I think that would be the very helpful things in the past, the integration, but they have to come out if we use the ISA 95 pyramid. It was come up from the bottommost layer, jump through a bunch of different systems before that's actually available. So to other system or to be consumed. But now, rather than having these hoops to jump through, we have a centralized hub to access the data equal for all the different parties and system. Okay. So there is the second question we frequently be asked from our customer previously. Okay. So it's been more than 10 years, and since the topic of the Industry 4.0 was raised back in 2012. But many companies are still struggling to nail down implemented OEE. And why is that? And what do you think is the key blocker that's actually preventing these companies from starting or getting any result from? And what's your point?
Okay, yeah, this is actually quite interesting because it's more than 10 years from the point of mentioning Industry 4.0 by the Germany Chamber of Commerce. But back even earlier, the concept of OEE has been around for longer than that. But people still get the implementations in a weird way. And one of the key reasons we saw from our experience is that they are not really taking into consideration what's actually happening on the floor, in particular with the people, where you have scheduled breaks that are not accounted for. Some cases where they are assuming that quality is 100% due to that the system does not do a certain quality control metric that can be referable, or they're doing it post-mortem, but the data is not being included during the calculations or being updated back in any ways. So we need to still label and also account for any plans in where the machine might be taken offline to be maintained as well, and actually look at it from different granularity depending on what you want to do. If you want to optimize the resource utilization of a specific single machine, you could probably look at it from a single point there. And also, if the point is to actually improve the efficiency of the whole line or cell, then the data should be accounted for in respect to that same granularity instead of skipping out certain data bits, which means the calculation will be off.
Right. So, okay, thank you for Ethan to putting into perspective. And I think probably in the past, because there was no insecurity regarding power and also the value of production. So looking at the big number, the low value and high value sort of cancel each other out. And we don't really see the actual problem in the system because overall it's look good. So now the details are starting to matter. Because of the carbon initiative and also the shortening of supply chain or the labor shortage, and everybody needing more efficiency to stay relevant and survive. And we can use IoT data and this out of the box ready system to help everyone to get a start and actual form their own strategy to build out the skill that's needed to move on. Okay, so okay. Do we have any question in the chat? Okay, well, okay, and our iFactory product architecture is very open, and you can use standard protocols such as Mobox, OPC-UA, or MQTT to convert data into the software. And also, this software is not limited to using only Advantech IPCs or the gateway, because the application scenarios are so diverse, and we are welcome partnership with professional with a professional partner in various fields. That will be the end today, and thank you for everyone joining.